In this video, we're going to talk about how to handle zero and negative exponents. So let's start with something that we know that will help us figure out what to do when we have a zero or a negative exponent. We're going to look for a pattern in the powers of 2. I'm just going to start with 2 to the 5th. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. And then I'm going to go to 2 to the 4th. 2 to the 4th power is 16. And then I'm going to go down 1. 2 to the 3rd power is 8. Then down, take my exponent down 1 again. 2 to the 2nd power is 4. Now what I want us to see is the pattern that's emerging here. Each time we decrease that exponent by 1, look at what's happening. We're taking this number and dividing it by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. So our next answer, 2 to the 1st, is 2, which makes sense because 4 divided by 2 is 2. And then what is my next answer going to be for 2 to the 0 power? Well, if I take this previous answer of 2 and divide it by 2, I get 1. So 2 to the 0 power is equal to 1. Now I can continue to follow this pattern, decreasing my exponent by 1. So now I'm at 2 to the negative 1, and taking my answer and dividing it by 2. 1 divided by 2 is a half. So 2 to the negative 1 is equal to a half. Again, I can decrease my exponent. Again, 2 to the negative 2 power. If we take a half and cut it in half, that's what dividing by 2 is like, cutting something in half. Half of a half is a fourth. So 2 to the negative 2 is 1/4. 2 to the negative 3 would be like taking half of a fourth. Half of a fourth is an eighth. 2 to the negative 4. Half of an eighth is a 16th. And then we'll go all the way to 2 to the negative 5 since we started with 2 to the 5th. Half of a 16th is 1/32, or 1/32. Now notice, this is not the only pattern that we see here that we're dividing by 2 each time. Notice how 2 raised to a negative exponent compares to 2 raised to the positive of those same numbers. So if 2 to the 1st is 2, 2 to the negative 1 is 1/2. 2 squared, or 2 to the 2nd power, is 4. 2 to the negative 2 is 1/4. 2 to the 3rd is 8. 2 to the negative 3rd is 1/8. Okay, so that's not a coincidence. And you can see if we try another number, similar things will happen. So let's do powers of 3, starting with 3 to the 4th. 3 to the 4th power is 81. 3 to the 3rd power is 27. And we can also get that 27 by dividing 81 by 3. 3 squared is 9. 27 divided by 3 is 9. 3 to the 1st is 3. So 3 to the 0, what will that be? If we continue to follow this pattern of dividing by 3, 3 divided by 3 is 1. Okay, notice 2 to the 0 power is 1. Well, 3 to the 0 power is also 1. In fact, any number or any variable raised to the 0 power will be 1 because of this pattern that happens. All right, let's see what 3 to the negative 1 is going to be. If we divide 1 by 3, we get 1/3. Okay, so again, 3 to the 1st power is 3. 3 to the negative 1 is 1/3. 3 to the negative 2 will be 1/9. 1 over this. 3 to the negative 3 will be 1/27. and 3 to the negative 4 will be 1 over 81. Just like up here, 3 to the 4th is 81, so 3 to the negative 4th is 1 over 81. So that pattern continues, and we can do that with any number or variable. So let's practice a couple. So if we have 5 to the negative 2, and I want you to evaluate that, we know that it's going to be equal to 1 over whatever 5 to the positive 2 is. 5 to the positive 2, or 5 squared, is 25. So 5 to the negative 2 is 1 over 25. If we have 4 to the negative 3, we know that that's going to be equivalent to 1 over 4 to the positive 3. 4 to the positive 3 is 64, so 1 over 64. If we have 10 to the negative 2, that's going to be equivalent to 1 over 10 to the positive 2. 10 squared is 100, so 1 over 100. Now, like I said, this works the same with variables. If we have x to the negative 3, we want to rewrite that as 1 over x to the positive 3. Now, we can't work it out or do anything from there, but we don't ever want to leave negative exponents in our answer. So anytime you have an answer or a problem that has negative exponents in it, oftentimes the directions will say rewrite with positive exponents only, or you need to make sure your answer has positive exponents only. So to rewrite something with a negative exponent, this is what you would do. So p to the negative 4 would be like 1 over p to the 4th. Now, another thing, if you have a negative exponent on the bottom of a fraction, what would you do? Well, when we had these, and these were technically on the top, if you had to call this a fraction, you could put it over 1. If you had a negative exponent on the top, we moved it to the bottom, and the exponent became positive. So if you have a negative exponent on the bottom of a fraction, you can rewrite that by moving this up to the top, and the exponent will be positive. Now, we don't have to put a 1 underneath it. You can, but you don't have to. So I've bumped that up to the top, which made it 3 to the positive 4, which is 81. Okay, same thing here. You have 1 over 7 to the negative 2. Okay, we don't want a negative exponent in our answer. We'll take that and we'll move it up to the top, and it'll become 7 to the positive 2, and 7 squared is 49. Okay, now we're going to keep going from there, because we're going to look at some more things that we could run into here. What about a fraction raised to a negative exponent? Okay, so we just talked about how if you have something raised to a negative exponent on the top, you can bump it to the bottom and the exponent will be positive. If you have something on the bottom, you can bump it to the top. So there's a couple ways to think about this. Now, everything in these parentheses has to be raised to this exponent. So if you wanted to, you could think of it like this first, that both of those, the numerator and the denominator, both need to be raised to that exponent. And then we have problems because we have negative exponents everywhere, and we don't want those. So since this one's on the top, I'm going to move it to the bottom and make it 2 to the positive 3. And I'm going to move this to the top, make it 3 to the positive 3. So I end up with 27 on the top over 8. Now, you can do that every time. There's one thing that we could do that might save us a little time, is if we can remember that when we have a fraction raised to a negative exponent, since this is what's going to actually happen, to just shorten the process, we can flip the fraction over, and that will make the exponent positive. Okay, it kind of just takes care of both of these in one step, by flipping it over and making the exponent positive. And then we'll do 3 to the third power is 27, and 2 to the third power is 8. So let's try another one like that just for practice. If we have 3/5 to the -2, we can flip the fraction and make the exponent positive, and then raise both the numerator and the denominator to that power. 5 squared is 25, 3 squared is 9. Okay, one more. If we have -5/4 to the -3, we can flip the fraction, make the exponent positive, raise the numerator and the denominator to that power. 4 to the third is 64. -5 to the third is -125. Now, we don't like a negative on the bottom of our fraction. This is just a positive divided by a negative. A positive divided by a negative is going to be negative. So you can either put that negative out front like that, or put it with the top number. Just looks better and is easier to read and easier to deal with. This fraction is negative. -64/125. Okay. Now, let's look at a few more things dealing with negative exponents. All right, one thing we want to be on the lookout for is something like this. And remembering how that's different than this. Okay. Here, the entire thing in the parentheses, the entire 5x is being raised to the -3rd. Here, the only thing being raised to the -3rd is the x. And so these are considered to be separate. And so here, if we wanted to fix the negative exponent, we would have to take the whole thing to the bottom, and that would make the exponent positive. And then we would have to raise everything in those parentheses to the third power. So 5 to the third power is 125, and then x to the third power. So that would be the answer for this one. Now here, if we want to fix the negative exponent, it's only being applied to the x. The 5 does not have a negative exponent. The 5 will stay on top. This will move to the bottom, and the exponent will become positive. All right, so this is the answer to this one. So you can see how they're very different. All right. Let's do a few more. A to the third, b to the -2 over c to the -5. Again, your instructions might say rewrite so that you don't have any negative exponents, or so that all of your exponents are positive. Other than that, there's really nothing that can be simplified, but like I told you, we don't want to leave negative exponents in our answer, and so this answer would not be considered, in simplest form. So the a to the third is good. We don't need to do anything about it because it's got a positive exponent. The b to the -2 needs to be moved to the bottom, and it'll become b to the +2. And the c to the -5 can be moved to the top, and it will be c to the 5th. And so really we've just kind of shuffled those around to get rid of all the negative exponents. Okay. Let's see. Now in that problem, all the variables were different. And so there was no simplifying necessarily that needed to be done. It was more like shuffling it around. Here, all of these expressions have an x as the base, so these can be combined or dealt with to make it simpler. And we want to make sure we're following our exponent rules. Exponent rules say if we're multiplying two things with the same base, we add our exponents. Well, a +2 and a -7, when we combine those, we get -5. And then on the bottom, we have x to the third. Now, this is division, and the rule for division is that we subtract our exponents. And so we're going to have -5 minus 3. Well, -5 minus 3 is -8. Okay, so this becomes x to the negative 8. But we can't leave our answer like that because it has a negative exponent in it. And so we're going to rewrite it as 1 over x to the 8th. Now I want to show you that there are other ways that you could have done this problem. And if your brain went in a different direction, that's totally fine. Let's look at that same problem again. And let's think of another way that we could have done this. Using our rules that we've learned. If you spotted that negative exponent right off the bat and you said, oh, I don't like that, I need to get rid of that, you could go ahead and move that x to the negative 7 to the bottom and make it x to the positive 7. And that way you've gotten rid of your negative exponents. At the beginning, you could apply your rule for multiplication here, which says to add the exponents. And then you would need to simplify this. This is division, so you need to subtract the exponents. 2 minus 10 is negative 8. And then again, we can't leave a negative exponent in our answer, so we would rewrite that as 1 over x to the 8th. Now you also have the ability to think about this right here as x squared on top and 10 of these x's on the bottom. We don't really like to do it this way because we don't want to write this out, but you can kind of think it in your head. This is x squared over x to the 10th. And if you simplify this by canceling like factors on the top and the bottom, all of your x's on the top cancel out, so you're left with a 1 up there, and you're left with 8 x's on the bottom. You see there are a lot of ways to get to that answer, 1 over x to the 8th. All right, I'm going to stop this video here. I am going to add another video with more examples, so if you feel like you need to look at a few more examples, go ahead and watch the next video as well.